In this video, we'll make this cool stepper motor, just as a way to learn what stepper motors are all about and how they work. If you've watched any of my videos, you'll see that I use these things a lot. These are stepper motors. And stepper motors are really nice for controlling things because basically you change the state of the input wires and the stepper motor will move one step. So with this particular motor, this is a NEMA 17 stepper motor. This motor, one step, every time you change the state of the wires, it moves there's 200 steps around it, so it moves 1.8 degrees every time you change the state of this motor. So you can control it, you can know exactly where things are by counting the steps that you give it. And of course the stepper motors come in a lot of different varieties. Here's another one. This came out of a DVD drive. So here's your stepper motor, and it turns this little screw and it moves the reader on the DVD drive back and forth. This is a 4-wire. And then here's a tiny one. I've used some like this on a few projects. That linear actuator project, things like that. So this is a tiny, there's your 4 little wires that control it, and then every time, this one I think is 20 steps per turn. Okay, so a lot of different teeny tiny things. So the basic way, when we're talking about here in this video, we're gonna be doing a 4-wire. Let's see, bipolar. Okay, 4-wire bipolar stepper motor. Alright, so here's one. See, there's 4 connectors there. That's a 4-wire bipolar stepper motor. And this too has 4 connectors. Those 4 tiny little pins that you can just barely see. This is a 4-wire bipolar stepper motor. Now this one's a little different. It has 6 wires, but basically 4 of them allow it to be run as a bipolar stepper motor. The other 2 are ground, and you just don't use them. So this is actually what they call a unipolar, or it's a dual purpose, unipolar or bipolar stepper motor. So we're going to just deal with this bipolar stepper motor. Okay, now basically the way that this works is you have 2 coils. So one coil is sort of arranged like this. Okay, and then you've got another coil of wire. Of course, that's what we're talking about. That kind of goes like this. And then in there, kind of where that X is a magnet of some sort. Okay. So, and usually that magnet can turn. So, you know, magnets have poles. So maybe there's a north pole here. Or what is it? Red for north, black for south. I can't remember. So you have poles on the magnet. And then, so if you charge this coil, it's going to attract one of these poles, the opposite pole. And then if you charge this coil, then it would attract a pole. And by changing the way that you charge these coils, you can make the magnet turn around, right? Usually these coils, they're labeled like this. So we would call this A, and then we might call this A prime. And then this would be B and B prime, right? So if we put electricity through this direction, it's going to create a magnet, and it's going to pull in one direction. And then if we put electricity through the other way, then it's going to pull with the opposite pole or repel. So that's why we call this bipolar. So sometimes we'll be running the current through this way, and then sometimes we'll be running it through that way. And so we can change the pole of this magnet and change which end of the permanent magnet that we attract, and that'll make it turn around. Same thing, we got to be in combination with two coils so that we can change direction. So let's say the black, whichever pole it is, the black's attracted here, then we want to make the black attracted here. So it's going this way. And then we make the red attracted to here, and it'll come up, and then the red attracted to there. You see, and we can pull, make this thing turn around whichever direction. If we did it in the opposite sequence, it will go that way. Okay, so 1, 2, 3, 4 wires, bipolar, because sometimes we go this way, sometimes we go this way, right? Bipolar stepper motor. Now, because now inside here they have really complicated structures so that you can get 200 steps or whatever out of this thing. Most NEMA motors or NEMA rated motors are 200 steps. But we can make something really simple just to learn about it. And because it's a magnet that spins, that's what a compass is, right? And if we take some wire and make coils, then we ought to be able to make this compass move around, right? So we'll make our own stepper motor. So basically what we're going to do is we're going to glue some of these on here like that, and then we're going to wrap a magnet. Now the way we're going to do it is we're going to make it where this one and this one, the wraps here and the wraps here, are one coil, and then the wraps here and the wraps here are going to be the other coil. Okay, so we'll have a pole here, and these will be opposite poles so that they'll attract the opposite ends of the compass magnet. And then these poles will be opposite, and they'll attract the magnet, you know, different ways. Okay, so we're going to make that compass magnet spin like that. All right, make sense? All right, I'm going to get the basics of this thing glued up. I've never done this before, but I just imagine it'll work. Okay, I've got my pegs glued on where we're going to wrap the magnet. Now, what I've done, I don't know if you can see this, but, well, two things. When I wrap here, I'm also going to wrap the same wire. I'm going to come under the bottom, and I'm going to wrap over here. I want them to go the same direction, okay, so that when we put the current to it, that it forms a magnet, and that this pole will be the opposite of this pole. So basically, so let's say the way we put the current through there, this is the north pole of this side, and this would be the south pole, then this would be the north pole, and this would be the south pole, so that this would attract one end of the compass magnet, and this would attract the other end of the compass magnet. So these two arrows will help me know which direction that I need to wrap. Now, I've also done it for the second coil. I want the first coil and the second coil to be wrapped in an identical fashion, so that we can, it'll just make it a lot easier for us to control things, okay? And then I have labeled this A, and here's A prime, here's B, and here's B prime. So it's going to be like that. There's going to be our A winding, and this will be our B winding across here. All right, now let's get started. Now what I have is some wire. This is pretty thin wire. It's from a little fan motor. It was a little AC fan motor, and this was the coil. It's nothing fancy. I don't know what diameter that is. It looks like it's about 10 thousandths or something, but I'm not sure. But I'm just using it. It'll work. It'll work fine. Okay. So it's just some surplus wire. So well, let me stick it over here, and then let's get started. So the first thing I'm going to do is tape this wire. Like, let's do A first. Where's A? There it is. I'm just going to show you how I get started, and then I'll change over and do it, get it all wrapped up. So we're going to start out by putting the This will be the A end of things. Okay. Hold on. A little balancing act here. All right. Make sure I have plenty of wire. I'm going to tape this down. This is our A wire. Alright, there we go. There's our A wire taped on. Now what we're going to do is we're wrapping so that the wire is going in this direction. Now I'm just going to do a wrap or two like this, get it all the way up to there, and then I'm going to come across, and I'm going to do this one first, okay? And then once I have this side done, then I'll go back and do this side, okay? And so it'll just come back down, and I'll finish up this side, and because I don't want the end wire to be on that end and come back. I want to be wrapping in this direction until I get back to here. I don't know how much I'm going to do. I think I'll probably do maybe 100 wraps here and 100 wraps here. So I'm going to go ahead and wrap this up. A little pun there. I'm going to turn the video off. I'm going to get this wrapped up, and then I'll turn it back on and see what's going on. Now I have wrapped the A coil. I ended up doing 128 wraps on both sides here. Now it's sort of neat, but this isn't rocket science, so you don't have to worry about it too much. We're just trying to create a little bit of an electric magnet. Alright, so that should do it. So here's the A going in, and the other end, which we marked as A prime, coming out. Now I'm going to shut off the video. Well, actually this goes like that. Okay, so I'm going to shut this off, and I'm going to go ahead and wrap the B coil across here, doing it exactly the same. See? Alright, nothing fancy, easy to do. Alright, now we have both the A coil and the B coil wrapped up. Now I guess if we did it in the picture, like it's in the picture, let's see. Now that's well, like that. Okay, so there's our A, the way we have it labeled, and here's our B, but we'll turn it over. Alright, now what I have here is a battery. This is just a double A battery, 1.5 volts, and I have burned a little of the varnish off the end here. You know, this is varnished wire, so you can't just stick a battery on there. You have to burn the ends off. Now, this is the test. So let me get the focus right. There we go. So when I connect this battery, what we should see... Oh, wait a minute. Is this the right one? Oh, yeah. Alright. When we connect this battery, what we should see is the compass jump. Well, it's already lined up. So let's unalign it. What we should see is the compass move and line up with this coil. Okay? So let's see. Ta-da! Alright. See that again? So the north-south of the compass is going to, it lines up with the axis of this thing. Now look, north is pointing down. Now if we reverse the polarity of the battery, it reverses the poles of the magnet, and north will point up. Okay? So one way we make north point the down or towards here, and the other way, if we reverse the the bipolar part, if we reverse it, then we can make north point in the other direction. Okay, so what we have created here is a stepper motor. Now the next thing we have to do is make this stepper motor run. So we have to have a way to make the current in these wires go the direction that we want. So we want the current to go through that way, current to go through that way, current to go in that way, and to go that way. So how are we going to do that? Well, what we have are some switches, okay? And we're going to do this with 4 switches. And each switch is going to be connected to the center, or each switch. The center of each switch is going to be connected to one of these wires, okay? And then the outside switches are going to be connected to either the positive or the negative terminal of the battery, okay? And that way, when we have these 4 switches, one for each side of the 2 coils, we'll be able to connect. So, you know, one way it'll be connected to the positive side of the battery, the other way it'll be connected to the negative side of the battery. So if we make this one positive and that one negative, then we'll have current flowing. You know, in case you don't know it, current flows actually from the negative to the positive. So the current will be flowing this direction. If we swap the switches, then it'll flow in that direction. So we'll be able to control that one and that one. Now, to make it a little easier, I made this little holder. Okay, so we'll go ahead and I'm going to wire this up. I'm going to actually do some soldering and get this thing all soldered up so it's just easy for us to work these switches right here. And we'll make, I'm going to use some colored wire. Okay, use this colored wire, and that's going to connect out here. Alright, so I'm going to go ahead and turn the camera off, get this thing wired up, get all the switches in here, everything wired up, looking good. Probably, I'll just rubber band the battery right here, and so we'll have everything wired up, and basically we'll just be able to work these switches and make this thing run, and then we'll run through all the different ways that you can turn a stepper motor, well, the bipolar stepper motor. Okay, so here we go. I'm going to go wire this stuff up. Okay, about an hour has passed, and what we have is I just put some wires. I soldered them onto the 2 leads here, soldered them onto the 2 leads there, and I put a little tape around there to hold everything in place, and then I've just taped this down right here. Now those wires, they run up to, let's see, my switches. What's up, switches? Okay, so when these switches are down, everything is connected to the negative side of the battery. As if I turn one of these switches up, you can watch, see the, ta-da, do you see it? Goes into alignment. Now it's pointing north. When I hit the switch, it goes right into alignment. Okay. On the bottom, it's real simple. Set up. Let me make sure it's focused correctly. All right. Here's your wires coming in. They go to the center of the switch. When you move the switch, it's either going to be connected to the positive rail or to the negative rail, and then I've just got this hooked on with a rubber band and some tape. The wires touching the battery terminals. Okay, so that's all that we have. And then this is everything's just connected up here. Now let me show you what we're going to do. Let's see. I'll do it. I'll write it over here. Okay, the way that the switches are, just like this, from this side over, they are lined up like this. See if you can see me right. Okay, they're in A, B, A prime, and B prime. Okay, so the current is always flowing from A to A prime, that would be down through this coil, or from B to B prime through this coil. Well, of course we might do it we'll do it the opposite way sometimes. So it'll be up and opposite way, this way. But so this one is connected to there, that's connected to there. Now the reason I put them in this order is you'll see it's a lot easier to go through the steps. Now we're only going to go through one full step sequence. We're going to use one coil at a time, and we're going to go through a full step. So that means that we have 4 steps for revolution. Okay, so here will be our steps. So step 1, step 2, step 3, and step 4. And then the 5th step will take us back to the state of step 1. Alright, now here's what we're going to do. If I put a 1, such as this, it means we're connected to the positive bus. If I put a 0, we're connected to the negative bus. Okay, so this means at step 1, A is going to be connected to positive bus. So that's this right here, it's connected to positive bus. B, all the rest connected to negative. So we're going to have current going from here to there. So from positive to negative. Right, it actually goes the other way, but we won't worry about that. And then these will both be at negative, B and B prime. They'll both be at negative, so we don't care. Right? Nothing will happen. There's going to be no current flowing through there, so there'll be no magnetism in this coil. But in step 1, we'll have magnetism in this coil. All right, step 2. So what that says is we're going to put A back down to ground. So A and A prime, they'll be at ground. Nothing will be happening here. But now we're going to put B to positive, and B prime is at negative, so we're going to get some current flow, right? So now this one's going to turn on, right? That's step 2. Step 3. If you know anything about binary counting, you could see that's what we're doing, right? 8, what is that? 8, 6, no, 8, 4, 2, and we'll hit 1 down here. Anyway, so at step 3, A is off, A is at ground, B is at ground, A prime is on the positive bus, and B is connected to the negative bus. Okay, so what that means is that now we have A opposite. The current in coil A is running the opposite. It was running, well, let's just say positive to negative. So positive to negative there, and now we've got positive to negative this way. So we've reversed the current in coil A, and it's going to attract the other way. Okay, and then the last one we're going to do, of course, is this. We're going to turn off all of A, and we're going to have the backward or reversed current in B. Okay, see that? So now B prime is going to be on the positive bus, and the current's going to be flowing over to, well, it goes the other way, but anyway, so it's going to be going to B. All right, so that's simple what we're going to do. So step 1, step 2, step 3, and step 4. And then to go back to 5, we're just going to, or step 5, we're going to go back to here and start over again. So what this is going to do, that's why I arranged these in this order, so it's easy for me to flip the switches. This is going to go through one cycle. Okay, so let's, oh, shook the camera, sorry. Alright, there we go. Get the camera back. There we go. Alright, so here are our switches. And we'll see in a little while how fast I can do this, but first couple of times through, we'll just go slow. Alright. Now here we go. We're going to 1. Step 1. Alright, see the north lined up. Well, it's going north, right? So looks good. Alright, now going to step 2, which means I got to turn this one back to ground and turn this one on. Alright, now the north is attracted over here. All right, now we're going to go to 3. So I got to turn this one on, that one off. There you go. North is going straight down. Okay, and then the step 4, I'm going to turn this one off and turn that one on. All right, and now north is facing that way, and then when I switch these to, we're back to step 1. Okay, that's how a stepper motor works. So we just make what these represent, or over here, these represent states. So when you change the state, if you do it in a sequence, if you do it out of order, it's just going to jump all around. But if you do it in the correct sequence, and there's several different sequences you can use. So this is just your plain one coil, sort of, I call it the wave drive, okay, where you're going from binary 8 to 4 to 2. No, let's see. 2 and to 1. So that's binary 1, binary 2, binary 4, binary 8. Is that right? Yeah, that's right. 1, 0, 1, 2. Yeah, that's right. Okay, so you're just changing these states. You change them in this order. Now you could do 2 coils, 2 coils, 2 coils, 2 coils like that. That would work. Now that's another way to do it. You get double the amperage as you go through it. Let me see. 2 coils, 2 coils. And then you can also combine the two, which is called a half step. So you could, enter. But don't worry about all that. Learn this first, and then you can figure out the rest. All right. So here is off. Okay. North is pointing actual north, which is, in that direction. All right. So now here we go. State 1, 2, 3, 4, back to 1, 2, 3, 4, back to 1. See, so we know exactly where that motor is according to how we do that. I don't know how fast I can do this to actually make it. Yeah, anyway. All right, so this is our stepper motor. This is what a stepper motor does. Of course, you get lots more steps per revolution. You get a lot of torque. You actually have something that is connected to the magnet so you can do some work. But that's essentially what a stepper motor is. So now that you know this, you can do anything with a stepper motor. You don't have to use switches. You can use your microcontrollers or your Arduino or something to do these switches for you. And you count the steps, you know exactly where you are all the time. That's what stepper motors do. So here we go. Oh, I'm not that coordinated. Let me see. All right, let's see how fast I can do it. Got to concentrate here. All right. Oh, let's see if we could go backwards. Oh, I didn't think about that. Yeah, nice thing. You can go backwards. So here we go, backwards. See that? Backwards. Now forwards. Now backwards. Let's see. That. Oh, screwed that up. Okay, anyway, now we're off. Yeah, so if you go this direction, changing your states, you go one way. You go this direction, changing your states, you go the other way. All right, that is about it. All right, I had to hook this thing up to my normal stepper driver. And this is about as fast as I can make this thing go. We're running this at 0.16 seconds between turns, or between steps. And that's about as fast as I can get it. You know, this is a fluid-filled compass, so that's about as fast as we can do it. Zooming.